In this video we'll be talking about depth first search. As the name itself implies that this algorithm is used to search a graph, a tree. So it can be applied on a tree, it can be applied on a graph. Various applications are available to it. It is a search algorithm to search for a particular node in systematic order. So we have two ways of searching a graph, that is either use depth first search or breadth first search. In DFS depth first search, which is DFS, we will be taking help of stack data structure. In BFS, which is breadth first search, we'll be taking the help of queue data structure. So today in this video we'll be talking of DFS, and in another video we have an example for BFS. So let us see what is the working principle behind it with an example. So as the name itself, these are the few introduction parts to it. So the algorithm works for weighted and unweighted graphs, works with directed and undirected graphs, can be used to attempt to visit all the nodes of a graph in a systematic manner. So you visit all the nodes in an attempt to search for a node in a particular order. That is what your DFS does. Okay, so consider this example. These are the nodes given to us. We'll be using a stack. Okay, so we know that in stack we have a pointer called as top, which is initially initialized to -1, and usually once we insert the elements, top will be pointing towards the topmost element in an stack, and only the element to which the top is pointed to, only that element can be deleted. Stack works on a principle of first in last out, or last in first out. The element which is inserted last will be the element to be deleted first. So you can see another video on stack which explains the entire concept for it. So let us understand this DFS. We'll try to explore all the nodes. We'll be seeing how to explore all the nodes in this list using the help of a stack. Initially we start from D, okay, and I mark D as visited. Okay, as soon as I mark D as visited, I push D into the stack. Okay, so I have top pointing towards the element D. Now what do I do is, once I am at D, I will try to explore all the nodes which are connected to D. Okay, all the outgoing edges. So here I have C, F and E. So what do I do is, I'll be visiting each and every node in alphabetical order. So C, F and E means obviously first C has to be visited. So what do I do is, I mark C as visited and I push C into the stack. So that is, I first mark the node as visited, then I push it into the stack. Okay, so this is the process which I follow. So this is what we will be doing. That is, first I have started with the node D. I have marked it as visited and I will be pushing it into the stack. So I'll be maintaining the order in which the nodes are visited. Next I have three nodes which are adjacent to it. So first I'll be pushing element C. I'll be visiting it, I'll be pushing it into the stack. Okay, so that is what we have done. So once I am at C, I don't have any way further. That is, I don't have any outgoing edges from C. There is no way further. So once I am stuck at some point, I will be removing. If I don't have a path to move along, so what do I do is, obviously I remove the topmost element of the stack, which is C, and I come to the previous top element, which is D. Now again at this point, what I have done, I have only explored a node called C, and what is the other edges which I have with respect to D? From D I can either visit F, either visit E. So what do I do is, so that is what we will be doing. So here there is no adjacent node to C, so I remove the topmost element, which is C. Okay, next what do I do is, I have two nodes, that is F and E, which has to be visited. As I have said, we'll be following the alphabetical order. So I'll visit E, I'll mark E as visited and I'll be inserting it into the stack. Then once I am at E, so I'll be moving only one direction, that is I'll be moving in one particular direction until unless I encounter a dead end. Once I encounter a dead end, again I come back to the node where I'll backtrack until unless I find another route to explore the graph. If there are no nodes in the stack, that implies that I have explored the entire graph. Okay, that is what it means. So at E, what do I do is I have only one option to move forward, that is G. So I mark G as visited and I insert G into the stack. Now from G I have two ways, that is I can either visit D or either visit H. D is already visited to me, I don't visit already visited nodes, so only one way possible is H. So I mark H as visited and I insert it into the stack. So at this point what happens is, at H there are two ways possible to me, either I can go to A or go to B. So I'll be using alphabetical order, so I'll be visiting A and I'll be inserting it into the stack. Okay, then at A I have only one option to move forward, which is B. Okay, so I mark B as visited and I insert B into the stack. Now once I am at B, I don't have any way further to move along. So what do I do is I come back to previous node. So what was the previous node? So I don't have any further way to move forward. So what do I do is I remove the topmost element of the stack. Now top is pointing towards the element A. Now I am at this point. From here also I don't have any directions further, so I remove the element top. Now top is pointing towards H. Again I come back to the H. Okay, in H also I don't have any direction further, so I remove H also. Then at G also I don't have any way further, that is I don't have any edges to an unvisited node, so I remove G also. So from E also I don't have any nodes to move forward, so I also remove E. Now at D I have one edge which points to F and it is not explored, so I mark F as visited and I insert F into the stack. Now at F I don't have any other nodes to visit. C is already visited for me, I remove the topmost F. I come to D. From D I don't have any other nodes to be visited, so what do I do is I also remove D. So if stack is empty, that means either I have visited all the possible nodes in the directed graph, and this array implies I have the number of nodes which I have visited, and this is the order in which I have visited them. Okay, so this order is nothing but as and when I visit them I have ticked it right, so I have written it down. So as you can see here, so first I have visited D, then we have visited C, then we visited E. That is, as and when we visit some particular node we have written it. So you might be in exams, they might be asking you, or in interviews, what is the order in which you have visited all the nodes when you use DFS on this algorithm. Okay, so this is a simple example for your DFS algorithm. We'll see a few more examples in later classes.